amplitude A. So it's just basically make a list of the letters you're given, okay? Lads. So look, A equals 5. Periodic time, T equals 2 pi over 7. Find its maximum velocity. So phi max is what, guys? Phi max is omega A, right? So what I know from the 2 pi over 7 is that the periodic times formula is 2 pi over omega. Directly from that I can say omega equals 7. Because 2 pi over 7 equals 2 pi over omega. Then all I have to do to find phi max is say, okay, you're going to be 7 times your amplitude, 7 times 5, which is going to be 35 is it meters per second? Yeah, because amplitude's in meters per second. Okay, so it's a very just fill it in sort of answer. Okay, find the maximum acceleration. So A max equals omega squared A. A max occurs when, guys? It's phi equals 0, yeah, but phi's not in this formula, so this means the displacement is A, but that's already included in the formula, okay? So it's just going to be 7 squared multiplied by 5, and what we should get there is, was it 175, is it? Oh sorry, yeah, 245. Please remember your units, ms to the minus 2. The average speed throughout one full cycle. The average speed in one full cycle. Okay? Now, average speed is distance divided by time. How much distance do you cover in a full cycle? Now, that's the tricky part, right? So, what you do is, you start off from the beginning, you're moving right. Okay, you start from the beginning, you're moving right. You cover 5 meters to get to here. You cover another 5 meters to get to the same position, moving left. Still haven't completed one full cycle. You get to here by covering another 5 meters. Then you come back to cover another 5 meters, and now you're back at the center, moving right. 4 times the amplitude is the distance covered in one cycle. Everybody got that? Distance covered in one cycle, 4 times the amplitude every time. So distance is 20. What's the time taken? 2 pi over 7. It's the period. Remember, the period's capital T is how long it takes you to get from one end back to the other end and then going back again. Okay? So it's 20 divided by 2 pi over 7, which is going to give us 70 over pi, we'll just put it in the calculator, 70 over pi meters per second. Are we happy enough with that? Okay. So, we'll skip on to question 3. A particle performs simple harmonic motion. Its maximum velocity is 6 and its maximum acceleration is 12. So phi max omega A, so therefore, and A max omega squared A. So you can see both formulas very similar, okay? And it goes, okay, the first one is 6, but the second one is 12. Can anybody tell me a really easy way to find out what omega is? Divide one equation by the other one. So I'm going to say 12 divided by 6 is the same thing as omega squared A over omega. What happens now? Omega A, yeah. A cancels. Omega cancels. Omega equals 12 over 6. 2. Omega equals 2. Is that right? Now, so that's find the periodic time. How do you find the periodic time? 2 pi over omega t equals 2 pi over 2. The answer being pi seconds. Okay? Find also the magnitude of its acceleration when the speed is 2 root 5. So what that question basically want to do is find A. What does the word magnitude mean? It means direction isn't important, as in acceleration of -5 is the same thing as an acceleration of +5. The magnitude is 5, the sign is irrelevant. That makes sense? Okay, so find A when phi equals 2 root 5. Okay? So guys, can anybody tell me, give me an equation that has both phi and A in it? Phi squared equals omega squared capital A squared minus x squared. Now, I currently only know V, I know omega, I want to find out, oh wait a second, wrong formula. Wrong formula. Speed. Oh yes. It's a two-step process, okay? So two-step process. An acceleration at any given point is minus omega squared s. We don't know what s is. So we need a way to find s using the information from v. We know v, so phi and s are in this equation here together. So if I know phi, I can find out what displacement I'm away from the centre that gives me that velocity. Then once I find out the s value, I can substitute it back into the a value. Okay? But I don't know the amplitude yet. Does anybody tell me what the amplitude is? WA equals 6, 2A equals 6, A equals 3. The amplitude is 3 meters, okay? So use this formula, we're going to get 2 root 5 to be squared. 2 root 5 to be squared equals omega squared, which is 2 squared, times 3 squared, minus whatever s squared is. So, what's 2 root 5 to be squared? I think it's 20. This here is going to be the number 4, so divide 20 by 4, and it's the same thing as 3 squared minus s squared. Okay, so what's 20 over 4? 5. 5 equals 9 minus s squared. Bring our s squared to the right, the 5 to the left. S squared is going to equal 4. S can be, technically speaking, plus or minus 2. Okay? But that's just the magnitude. That's just going to change the direction. They're both going to be the same magnitude. So just use s equals 2. Therefore, your acceleration. Okay. Your acceleration is minus omega squared, which is minus 2 squared, times s, which is going to be another 2, and it'll give you minus 8 or plus 8, right? So the acceleration was of magnitude 8 ms to the minus 2. Okay, so moving on. To do question 4. So 1, 3, and now we're on 4. A particle performs simple harmonic motion about a fixed point 0. When it is 1 centimeter from 0, its speed is 8. When it is 7 centimeters from 0, its speed is 4. So you're basically at the blue point A. At point A, your velocity. Now we don't know the direction, but we know it's symmetrical. So we know that when that distance is 1, when s equals 1, the v value, whether it's going to the left or going to the right, it's going to be 8. Then we have a second point. which is 7 centimeters away, and it's going slower because the acceleration is slowing it down because it's getting further away from the black equilibrium point. Okay, so its phi is going to be 4. Find the amplitude. I need a formula that links S and phi together. I need this. S and phi together. Any takers, guys? Phi squared equals omega squared A squared minus S squared. Okay. Now, here's an interesting one. Let's do the first one. 64 equals omega squared A squared minus 1 squared, right? And 1 squared being the same thing, just as 1 basically, right? So 1. What about the second equation? Using S equals 7. 16 for phi squared, isn't it? Because 4 squared, 16. Omega squared stays the same. A squared, anybody? We don't know yet. And then S squared, 7 squared, which is 49. Now, there's a really, really easy way of doing this, and you're going to find you're going to do this trick a lot. Just going to divide them, top by bottom. So 64 divided by 16, 4. Omega squared divided by omega squared, no need to worry about that. A squared minus 1 equals A squared minus 49. We're about to get a quadratic equation of some sort, don't know which type yet. Cross multiply. 4A squared, what's 49 times 4? 196, is it? Bring the A squared to the left, 5A squared. Bring the 196 to the right, 195. Divide the 195 by 5. What was it? Is it 39 or something?
Is that supposed to be 3A squared?
Yes, it is. Excuse me. It's 3A squared. That'll explain the weird number, won't it? 3A squared. So divide 3 into 95. Sorry? Okay. Still a weird number. A squared equals 65. A equals the square root of 65. That's allowed, like, it doesn't have to be perfect, like. So we're correct. A equals root 65. Okay. Well, now, what about we found the amplitude, done. The periodic time, guys, what's the crack with the periodic time? How do we figure that out? Periodic time is what formula? Do we know what omega is? Not yet. But we have formulas that had omega in it. So an example would be the 16 equals omega squared. It used to be A squared minus 49, but we now know what A squared is, don't we? So what's A squared? Sorry? 65, okay, so we have our 65 here. Okay, let's try this for a third time. 65. Okay? So 16 equals 16 omega squared. Omega will equal 1. Because, so you should go with the positive value there, lads, okay? Not the negative. So omega squared, okay? How many complete oscillations does it perform in 1 minute? Okay? What's a complete oscillation? A complete oscillation is where it completes its full cycle. And how long does it take to do a full cycle again? What's the word we use? How long does it take to go from here, back again, back to where you started? It's called the period. 2 pi over omega. And the answer to part 2 was that the period is what we're looking for. It was 2 pi over 1, which therefore equals 2 pi. 2 pi is how long it takes us to do one oscillation. It wants us to find out the number of oscillations we can do in a minute, right? So number of oscillations. So you have to remember that your 2 pi is in seconds, not in minutes. So it's going to be 60 seconds divided by 2 pi. What's 60 divided by 2 pi?
9.5.
Sorry?
9.5.
9.5. So this is question. Oh, sorry guys. Did I get my questions mixed up? Yeah, sorry. I end up doing 6 part 3 as opposed to 4 part 3. But look, both questions are the same. So excuse me. I end up doing how many complete oscillations it'll perform. And what did you say it was?
9.5.
So 9.5, look, that'll cover question 6 then. You just divide it, you divide your seconds by the periodic time, okay? Now, to do 4 part 3, find the speed of the particle when it passes through 0. What's the speed of the particle when you pass through the middle? It's your phi max, isn't it? And your phi max is, anybody? Omega A. And what did we say omega was again? Omega is 1. And what's the amplitude? Root 65. So the answer for phi max is just going to be root 65. Okay. Question 6 is the same thing as question 4. It's one of these division ones. You do exactly like this. Only difference is the last question, and I already did that for question 4, okay? So we can move on. Okay. The tides are assumed to rise and fall with simple harmonic motion. At 12 noon, the depth of the water in the harbour is at its lowest. Okay, so what you can say here is that if you were to run a model on this, what you say is that imagine the depth of the harbour is at its lowest. So you would say it starts off here at a minus amplitude, and this is at 5:30. Is it 5:30? 12 noon. Okay. Then what happens next is at 12 noon it's a depth of 3 meters. Yeah. Happy enough with that? So what happens next is it goes at 5:30, which is 3.5 hours later. It shows its greatest depth at 13. So it goes on its way up, and now it's at 13. Okay, and it hits the, what's the in-between point, guys? What's exactly halfway between 3 and 13? 8. So you have 8 in between. Okay, so I'll leave out the time for a minute. Okay, so basically you can model this full thing. If I move my axis down and add in some value, I can base it off a cosine function, where it goes to 8, and now it's returning back down again, and then it's going back up again. 8 is the middle value. So if you imagine 8 as a sort of like it does an ad hoc x-axis, the tide bobbles up and down, above and below 8 meters. Would you agree with that? So therefore the full system can be based off simple harmonic motion. Okay? So, what is the amplitude? I think we just found out a second ago, didn't we? Anyone tell me? The amplitude is 5. 5 meters up above and below the middle value. What's the periodic time? Now, periodic time, okay? When it goes from one amplitude to the other amplitude, how much have we actually covered? What fraction of the periodic time have we covered? Half it. So when you go from one amplitude, which is here at point A, and you go all the way over to point B, you've covered half the distance of one oscillation. Then when you go all the way back, you cover the second half. So t over 2, half your periodic time equals how much hours and minutes? From 12 to half 5. So 5.5 hours, yeah? Well, so 5.5 hours. So what's the periodic time then? 11. T equals 11. What is the earliest time in the afternoon that a yacht can sail? What do we need the yacht to do? It has to wait till 10. Do you understand? 10. Okay? Now, if it has to wait till 10, we're talking about this point here, aren't we? We're not talking about this one here, and we're not talking about this one here. It will keep hitting 10 as time goes on, but we want the very first one. Okay, just come in handy for your job, Tom. Okay, so what we have here, guys, is what's the earliest time in the afternoon that the yacht can sail? Okay, so we want an x value of anybody? Sorry? We want an x value of, it would be technically 10, wouldn't it? But because we're modelling this on a cos function, how far above the x-axis are you? It's technically 2. So if you imagine 8 meters as your baseline, so basically 3 meters is 5 below, and 13 meters is 5 above. Would you agree with that? 3 meters is 5 below your x-axis, 13 meters is 5 above your x-axis. We're starting off at the extremity because we're starting off when the tide is at its lowest, so we're starting off at the amplitude. So if you read your notes, okay, what it says is that when you start off at the lowest point, you have to use a cos omega t. This is the only function that links your displacement to your time. So displacement will be 2. What's our amplitude? Is that good? What's our amplitude? 5. We don't know our omega value yet, and we're looking to find out. We want to find out what t is. Okay? So look at this. This is an important one. Okay? So we said that capital T is 11. Yeah? And 11 equals 2 pi over omega. Cross multiply, omega equals 2 pi over 11. Substitute in 2 pi over 11. So it's going to be 2 pi over 11 t. And here's the fun part. Bring down the 5. 2 over 5 equals cos 2 pi over 11 t. Cos inverse 2 over 5. So what happens when you cos inverse 2 over 5? Can somebody tell me? I want it in radians as well. What we have here, guys, is that when we cos inverse this, we're going to get 2 pi over 11 t ends up to be equal to, what did you say it was? 1.16. Now guys, just a quick note, see this 1.16, yeah? The 1.16 is for the first answer, which is located here. If you wanted to get the second answer, you'd have to, like, remember what you said, you keep going down your quadrants to get the second answer. Then you'd add on another 2 pi to get the third answer. So remember, there can be more than one answer if you're looking for the times, plural, but we're only looking for the first time. So, find out what t is, guys. T is going to be 11 times 1.16 divided by 2 pi. Once you give me that, you're done. How many hours later does it take for us to find that height? Put that into the calculator, quickly.
2 hours.
Is it 2 hours on the dot?
2.03.
2.03 hours. So 2.03 hours added on to your 12 noon. You started at 12 noon, didn't we? Add on 2.03 hours, it's going to be 2.03. Change your 2.03 into hours and minutes. You can use it using the DMS button here. So where's the DMS button? That button there. It's basically 2 hours and 2 minutes. So 2 hours, 1 minute and 48 seconds, which is basically 2:02 p.m. Okay guys.